let's talk about algebra and chemistry. Now, none of us like math. Well, some people like math. I don't like math, mostly because I'm bad at doing it in my head. But that's why we invented calculators. But the thing is, chemistry math can look really, really intimidating, but it's actually basic algebra, which, might not be a comfort to a lot of people, but it really is straightforward math, mostly multiplication and division, a couple of exponents. But if we can just, kind of rub off the dust of math and get us in the right mindset, then the math in chemistry is actually very approachable from a math standpoint. It's not calculus. It's not geometry or trigonometry, or it doesn't get complicated. So it looks complicated, but it looks more complicated than it actually is. So let's just jump into it and talk about algebra and chemistry. Let's start by reviewing some really important algebraic concepts. And a lot of these are very straightforward. So we'll talk about properties and laws, the order of operations, super important, just a little bit on exponents and logarithms, and then we'll look at solving for x and do some practice. So the algebraic properties and laws I want to talk about, some of these are very straightforward, but again, very important. So the first is the annulment property, which basically says that x times 0 equals 0. Anything times 0 equals 0. Pretty straightforward. I don't think that's in dispute. The next one, identity. Anything times 1 equals itself. So x times 1 equals x. That seems pretty obvious, but what's important is we can rearrange this to get that x over x equals 1. So anything divided by itself equals 1. Going to be super important when we're talking about dimensional analysis. The next three properties are a little less obvious how you're going to use them. But the commutative property states that x times y is equal to y times x, so the order in which you multiply things doesn't matter, which when we look at PEMDAS, that's how that plays out. The associative property, x times parentheses y times z is equal to parentheses x times y times z. And the distributive property, x times y plus z is equal to x times y plus x times z. That one you'll probably see come up a little more. The commutative and the associative properties are important. You don't really need to think about them when you're doing algebra too much, because for the most part, you're not going to do a lot of rearranging, just some. It's mostly going to be laying out equations, just multiplying through. So, order of operations. Now, this is absolutely, crucially, 100% important, and the reason is because your calculator will always, 100% of the time, guaranteed follow this order of operations. I cannot tell you the number of times I have seen a student show me their work, and their work is perfect. They set up the equation exactly right, but they got a completely wrong answer. And it's because in their calculator, they did not put in the appropriate syntax. So the calculator, which just follows order of operations, it doesn't think, it just follows a set of programs, right? A set of rules. And in this case, the rules are the order of operations, and spits out technically a correct answer for the calculator, but because it wasn't put incorrectly, it didn't spit out the correct answer. So here's the order of operations. First, parentheses, then exponents, then multiplication and division, equally weighted, then addition and subtraction. So let's look at an example. So say I have this equation, and I want to start simplifying it. Well, the first thing I'm going to do is look at the parentheses. Now, what's important here is that within parentheses, it's kind of like Inception. Within parentheses, you follow PEMDAS. So within parentheses, you would look for first parentheses, then exponents, then multiplication, division, then addition, subtraction, and so on and so forth. So the first term in parentheses, 65 times 34, there's only one operation, so we're just going to do that. But the second term, right, we have 3 cubed times 102. Exponents come before multiplication division, so we're going to actually do the exponent first and then do the multiplication. So the first term, 65 times 34, is equal to 2210. The second term is 3 cubed, which is 9. 9 times 102, which is 918. So we simplify that equation. Next thing we want to do, look at the exponents. Okay? All right, exponent second. So we're going to square both those numbers, and we're going to generate some big numbers. Big numbers. So third step is multiplication division. So we're going to look at the left and say, okay, going to multiply that first, then subtract the number on the right. And now we get a really big number, but we just talked about scientific notation. We can report this in scientific notation to make it much easier to figure out how big is this number. It's 1.96 times 10 to the ninth, so it's about 1.96 billion, almost 2 billion. So Order of operations, super duper important. Make sure you're paying attention to it. If you're writing things out, when there are implied parentheses, as you'll see when we're doing dimensional analysis. If you put a bunch of stuff above a line and a bunch of stuff below the line, it's implied that the stuff above the line is in parentheses and the stuff below the line is in parentheses. So important to know when you're writing out things, sometimes you don't write all the parentheses in there. Exponents. Okay, so an exponent is basically multiplying a number or variable by itself. For instance, 2 cubed is 2 times 2 times 2. And then the rules for exponents that you need to be aware of are when you're multiplying the same base number with different exponents, you add the exponents. And if you're dividing, you subtract them. For instance, if you have 10 to the fourth multiplied by 10 to the minus 7, that's equal to 10 to the power of 4 plus minus 7. So multiplying them together, add the exponents, which is equal to 10 to the minus 3. If you're dividing them, 10 to the 12th divided by 10 to the 9th, that's equal to 10 to the power of 12 minus 9, or 10 to the third. This is really important because we're going to be doing a lot of this in dimensional analysis, because if I have something in kilometers but I need millimeters, how do I convert from kilometers to millimeters? It ends up being something like 10 to the whatever over 10 to the whatever. So you're going to be doing a lot of simplifying exponents. Logarithms are related to exponents, and it's basically the power you need to get to the number you want, which sounds really weird, but to put it in a mathematical form, if a to the x equals b, then log of base a, the logarithm of base a of b, is equal to x. So 10 squared is 100. 10 to the second power is 100. Log base 10 of 100 is equal to 2. Now, most of the time, you're just going to see log with no base. So if you see log with no indicated base, that means it's base 10. So if there's no number, if it just says log 3, then it's saying 10 to what power gives you 3. So if it doesn't say anything, it's log base 10. So some rules for logarithms. First, log of a to the x is equal to x log a. So if you're raising a power within a logarithm, you can move the exponent in front of the logarithm. Log of x times y is equal to log x plus log y. Log of x divided by y is equal to log x minus log y. This is important because, again, generally there's one variable we want to isolate. So if it's in a logarithm, you can separate that out. So if it was log of 2x, it'd be log 2 plus log x. If it was log x over 2, it'd be log x minus log 2. So finally, the thing you need to know is that 10 to the power of log x is equal to x. So 10 to the power of log 2 is equal to 2. Now, logarithmic functions, again, a difference of 1 is a power of 10. So there are a couple of different scales we look at that are logarithmic: pH scale, the Richter scale, decibels. Those are all logarithmic, meaning a difference of 1 is a power of 10. So if you think about pH 7 as neutral, well, pH 6 is 10 times as acidic as pH 7. pH 5 is 100 times as acidic as pH 7, and so on and so forth. One other thing about logarithms that you're going to see a lot is natural log, ln, and that just means log base e. So it follows the exact same rules and laws, but it's in base e. So let's look at a couple of problems. So if we want to solve for a variable, we simplify the equation, we do the same thing on both sides, and then simplify the equation, and then just do that over and over and over again until we have x by itself. So for instance, if x plus 5 equals 3, we can subtract 5 from both sides and simplify to x equals minus 2. If we have x over 3 is equal to 4, we can multiply both sides by 3 and simplify to x is equal to 12. If we have x squared equals 9, getting a little more complicated, we can take the square root of both sides. Square root of x squared is equal to square root of 9, and simplify that to x is equal to 3. And then if we have something like log x equals 3, 10 to the power of log x equals 10 to the power 3. So x is equal to 1,000. So let's look at some example problems. Simplify the following expression. 7 divided by 2 minus 4 times 2 in parentheses squared plus 5 minus 5 divided by 2 cubed. Okay, following PEMDAS, right? We're following PEMDAS, so we're going to say Where's my pointer? Here he is. We're going to say, okay, multiplication and division first. So within the parentheses, multiplication and division first in that order. So this is the first thing we're going to do. We're going to do that. 1, 2, 3. Okay. Over here, we're going to do 1, 2. So we're going to do 7 divided by 2 minus 4 times 2. And then over here, 5 minus 5 divided by 2. So 3.5, right, minus 8 plus 5 minus 2.5. Okay? And now we'll do the addition of subtraction. Minus 4.5 squared plus 2.5 cubed. Now we do the exponents. 20.25 plus 15.625. And then we add those together. 35.875. If we want to solve for x, okay, we got 3x plus 7 is equal to 9x minus 4 over 6. So first thing we're going to do, multiply both sides by 6. So 6 times, and again, we're distributing it, right? So we're multiplying the whole side by 6, okay? So we're going to get 6 times 3x, and then 6 times 7, plus 6 times 7, okay? Here, it's this term, this whole thing, we're multiplying this whole thing by 6, so the 6 here, those are going to cancel out. So we get, on this side, 18x plus 42 is equal to 9x minus 4. So now you could rearrange this in any way, but generally you want to leave a positive power of x, or you got to multiply by -1 at the end. So what we'll do is we'll subtract 9x from both sides, okay? And we get 9x plus 42 is equal to minus 4. Then we'll subtract 42 from both sides, and we get 9x is equal to 46. Divide both sides by 9, and we get x is equal to negative 5.11. So, some practice problems for you again. I recommend you pause and then work it out. So, simplify this following equation. Pause the video and work it out. All right, so again, following PEMDAS, we're going within this parentheses first. And again, this is where, when I said implied parentheses, this whole bottom part is in parentheses. So I've got 4 squared times 3 plus 9 minus 7 squared. So within the parentheses, I'm going to do my exponents first, okay? So that becomes 16 times 3, right? Then I'm going to multiply that together. So that becomes 48 plus 9 minus 7. Okay, so 48 plus 9 minus 7 is going to give you 50. Okay, squared divided by, again, 9 times 2 cubed. So 2 cubed is 8. So 9 times 8 is 72. 7 times 4 is 28. So 72 plus 28, which is 100. So that is equal to 2,500 over 100, or 25. Okay, then I want you to solve for x. So pause the video and solve for x. All right, so I've got 2x squared plus 9 minus 4 over 3 equals 9 plus 7. So on this side, I can just simplify this on this side right away and turn that into 16. Then I'm going to multiply both sides times 3. Okay, and I'm going to get 2x squared plus, I can simplify this because it's in parentheses, so this is 5. 2x squared plus 5 is equal to 48. Subtract 5 from both sides, 2x squared is equal to 43. Divide both sides by 2. X squared is equal to 21.5. Take the square root of both sides and get that, whoops, I can do this. X is equal to 4.64. So that's, in a nutshell, the math you're going to be doing. So definitely give it some practice. Make sure you, especially with PEMDAS, practice punching things into your calculator. So like for this problem over here, right? If you just put into your calculator, if you just did this in order, right? You just did 4 squared times 3 plus 9 minus 7. Even if you got the parentheses and squared it, and then just put divided by 9 times 2 cubed plus 7 times 4. Let's punch that into our calculator and see what we get. So parentheses, 4 squared times 3 plus 9 minus 7 parentheses squared divided by 9 plus 9 times 2 cubed plus 7 times 4. Okay? And you get something in the order of 2250. Okay? Because what your calculator does is it calculates this term, then divides that by 9, then multiplies the result of that by 2 cubed, then adds 7, and then multiplies the whole thing by 4. So it's really, really important that you follow order of operations because your calculator always will.